Hey guys, this is Megan again, and welcome back to OnlineMathCircle AIME video tutorials. Today we are going to talk about 2009 AIME I Problem number 3. A coin that comes up heads with probability p greater than 0 and tails with probability 1 minus p greater than 0 independently on each flip is flipped 8 times. Suppose the probability of 3 heads and 5 tails is equal to 1 over 25 of the probability of 5 heads and 3 tails. Let p equal m over n, where m and n are relatively prime positive integers. Find m plus n. So first of all, we have 8 flips, and we want to pick 3 of those flips to be heads. The number of ways we can do this is 8 choose 3. The probability of picking 3 heads with the probability of 1 head being p is p cubed. And the probability of picking 5 tails is 1 minus p, quantity raised to the 5th power. So the probability that we have 3 heads and 5 tails is equal to 8 choose 3 times p cubed times 1 minus p raised to the 5th. Now, in order to pick 5 heads out of those 8 flips, we have 8 choose 5 ways of doing so. This is the same thing as 8 choose 3. And the probability of having 5 heads is p to the 5th, and the probability of 3 tails is 1 minus p, quantity cubed. So the total probability of picking 5 heads and 3 tails is equal to 8 choose 3 times p to the 5th times 1 minus p, quantity cubed. The original problem statement says that the probability of 3 heads and 5 tails is equal to 1/25 of the probability of 5 heads and 3 tails. Putting this statement in equation form gives us 8 choose 3 times p cubed times minus p, quantity raised to the 5th, equal to 1 over 25 times 8 choose 3 times p to the 5th times 1 minus p, quantity cubed. Now we have to solve this equation for p. We can start off by canceling 8 choose 3 from both sides. And we can divide both sides by p cubed and both sides by 1 minus p, quantity cubed. That leaves us with 1 minus p, quantity squared, equal to 1 over 25 times p squared. And multiplying both sides by 25, we can get rid of the fractions. And we can square the left-hand side, expand that out, and then put all the terms on the left-hand side so that we make a quadratic equation 24p squared minus 50p plus 25 equal to 0. Solving this quadratic for p, we can factor. And that gives us 6p minus 5 times 4p minus 5 equal to 0. Solving for that gives us p equal to 5/6 or 5/4. Since p is the value of a probability, it must be less than 1. So we cannot have p equal to 5 over 4. And that leaves us with p equal to 5/6. Now the original problem says let p equal m over n, where m and n are relatively prime. So in this case, 5 and 6 are relatively prime because their greatest common divisor is 1. So we must find m plus n. So in this case, m is equal to 5 and n is equal to 6. So our answer is m plus n, which is equal to 5 plus 6, which equals 11.